Hi there. Let's talk today about how to get interactions between a categorical variable and a continuous variable. So here's what we're going to be shooting for. We're going to be looking at a data set published by Aiken and West in their book on testing interactions. And the final result is what you see here. They were looking at the relationship hypothetically, between GPA, the grade point averages of students graduating from various colleges, whether or not they graduated with a liberal arts degree, a business degree, or an engineering degree. And the dependent variable was after that bachelor's degree, what kind of salary that they obtained. This book was published in about 1991, so those salaries are lower than what you'd expect by today's standards. But that said, what we see here is that liberal arts majors are being paid the least. Then business majors are being paid more, and then engineering majors being paid the most. We see in this that the slopes differ. It looks like there's hardly any slope. In other words, GPA doesn't matter hardly at all for the engineering majors, does matter for the business majors, and it looks like it probably matters a little bit for the liberal arts majors. So uh, with the business majors, the higher the GPA, the higher the salary. So what we're going to do is we're going to look and see how we got this data, how we plotted it. I'm going to do that a couple of different ways. Okay, here's my data and my syntax file. And I have 3 levels of college: liberal arts, engineering, business. Those are coded 1, 2, and 3, with liberal arts being coded 1. So if I go ahead and over here show you the coding scheme, it is liberal arts 0, 0. Engineering is 1, 0. And business is 0, 1. So that's what I'm going to use as my coding scheme. The liberal arts are starting off as 1s, engineers as 2s, and business as 3s in the data set. I also have GPA, I have the salaries. We're going to ignore these parts of the data here for our purposes right now. Okay, I'm going to first go ahead and start by centering GPA. I'm going to take this step by step so you can see how it's working. So when I would first go to descriptives, look at GPA, find that my mean is 2.777, so I rounded it off at 2.78. And so I wrote compute center GPA is equal to GPA minus 2.78. SPSS ends with a period as if it was a sentence. And then I said execute, so the numbers would show up. And so there I've created a column of GPA scores. Next, I'm going to create my 2 dummy codes. Instead of calling them D1 and D2, I'm going to call them engineering and business. Give them meaningful names based upon the coding scheme, coding them in terms of what I've labeled as 1. So engineering has a 1 for dummy code 1, so I call dummy code 1 engineering. Business has a 0, 1, that's dummy code. 2 is the 1, so I call the second dummy code business. And so I'm going to just run this part right here to start off with. So here are my 2 dummy codes. I've started off by this calling for the whole data set, compute engineering equals 0, compute business equals 0. And so now I have zeros all the way through. Then I'm going to go ahead and change the engineers to 1, the business to 3 by saying if college, my variable over here is equal to 2, I want the engineers over here to be 1. And if the business is over here is 3, then I want business over here to equal 1. So I'm going to go ahead and run that. And got ahead of it and missed it. Go ahead and run that. And I have 1s and 1s where I wanted. Finally, I'm going to do the interactions, and the interactions is going to be, I'm going to call that engineering interaction, business interaction. I'm remembering that I'm doing that as a function of GPA. So these are centered interaction terms. And so I'm going to get engineering times centered GPA, business times centered GPA. So interactions is multiplying dummy code by the continuous variable. Every place that we have dummy codes of 0, it ends up being a 0 in the interaction term. And any place that it's a 1, we end up copying over the centered GPA. It seems weird, but it works. Okay, that sets us up to run our regression. I'm going to run the regression in steps, and here's the syntax for that. But I'm going to go ahead and run it point and click so you can see it. So I'm going to go ahead and put in, to start off with, engineering and business looking at salaries. So my 2 dummy codes in 1 set, and hence a block. Then I'm going to go ahead and put in centered GPA. And then I'm going to do a third block where I put in my interaction terms. I'm going to go ahead and make sure to click R squared, change, continue. All this is the same as what's in the syntax here. Okay, and here's my output. Starts off regression, shows me what I entered on each of the 3 steps, 1, 2, 3, to get 3 models. The first model is accounting for 97% of the variance, and it comes about from having a hypothetical and small data set. So that's significant with 700, an F of 743 with 2 and 47 degrees of freedom, highly significant. GPA is then accounting for 1.7% of the variance and is significant. And then the interaction accounts for uh, 0.7% of the variance. That is not a lot, but there's very little error, and it is significant. The advantage of looking at it this way is that you can refer to these effects in ANOVA style language. That is, I can say the effect of college major is significant in step one, that GPA is significant in step two, and that the interaction between college major and GPA is significant in step three. And I focus on my F changes, not the ANOVAs down here where it's just building a more and more, larger and larger model. I'm then interested in looking at my coefficients. I'm not, since I centered, I don't see any big changes between what happened at step one, step two, and step three. So hence I can go down to step three. In step three, I can see that my constant was 20,000, basically around $20,000, $21,000, 2983. This gets interpreted, as do all terms, when the other terms are zero. So if I've zeroed out GPA and zeroed out my dummy codes, then I'm talking about the liberal arts majors. And since I center GPA, I'm talking about that when they have an average GPA. So liberal arts majors with an average GPA of right around 2.78 are expected to make $21,000 coming out of college. Engineering majors add on to that $21,000 another $7,000, and that's a significant increase with a whopping t-value of 62. The business majors also have a significant increase above the college, above the liberal arts majors of 26,000. The degree to which center GPA makes a difference is $789 for a 1-point jump. This applies to the people zeroed out everywhere else. So that means that it's for the liberal arts majors. A liberal arts major at an average of 2.78, as we saw when we did our descriptives to find what the average center GPA was, would be making 21,000. If you go up 1 point on GPA, so a 1-point increase from 2.78 would be 3.78, those people are expected to make an extra $789. And that is a significant slope. The engineering majors, we see a minus 667. This is a difference in slope, and it refers back to the initial slope represented here by our x value. So relative to the liberal arts majors, the engineering majors have a slope that is $667 less than the liberal arts, which would leave them about 123 for a 1-point increase. Not much, and that is, we don't know what the slope, the simple slope is yet, but we do know that this is a significant difference. It's a significant decrement of the slope relative to the GPA the effective GPA for the liberal arts majors. And then finally, for the business majors, their slope is $1,000 more for a 1-point GPA, going from a 2.78 to a 3.78 relative to the liberal arts majors. So that would make them about $1,800 and something dollars. These significance values are basically, is this decrease significantly different than this 789? Is this increase significantly different than the 789? Okay, so when you have an interaction effect, just like in ANOVA where you should look at the simple main effects, here we should look at the simple slopes. How do we get the simple slopes? There's an easy way to do that in SPSS, and that is just go to data, do a split file command, and when you split the file, you're going to compare the groups across colleges. So use your categorical variable and don't use the dummy code, use the variable name that refers to all the different categories so that it gives you all 1, 2, 3 or 1, 2, 3, 4, depending on how many categories that you have, all in one split. So we say split the file, and then we're going to go and analyze regression, linear, and I'm going to reset this, and I'm just going to look at how salaries function as with respect to center GPA. So just look at my continuous variable on the dependent variable alone. When I run that, what I end up getting is an analysis in which it's for each of the colleges, it's running that simple regression. And you can see here the model summaries. It's doing the model for the liberal arts major, the model for the engineering major, the model for the business major. And what I'm really interested in is down here at the bottom. And here it is in looking larger. So I have the liberal arts. This is the same information that was in the original output. So that you can see right away when you just do your initial run. And it is showing that this is a significant simple slope. All you need is a constant and a slope to be able to plot a line. So that information should allow you to plot a line. You just need a couple of x values so that you can get a couple of points, and then you can plot it. Then we have the slope here and the intercept for the engineering majors. This slope is not significant. They said that it was going to be around 123. It's 122.874. And the constant is 28,000. They're making $28,000 a year compared to the liberal arts majors making $21,000 a year on average. And then we have the business majors, and their slope is 1871. That is a significant simple slope. And there is the constant for that. So showing this mathematically, what we've just done is to basically look at this equation here, where I have a continuous variable, a set of dummy codes. I put that in brackets to represent the fact that together they represent the effect of major, two dummy codes, or a set of dummy codes to represent major. That's one variable, and then another variable in brackets to represent the interaction. So you can think about this in ANOVA terms. Here's my continuous variable. Here's my college major. Here's the major by college, sorry, major by GPA interaction. This shows it laid out in terms of names of the dummy codes, multiplying business by GPA, engineering by GPA. This shows it making clear that I've centered GPA, so that I have centered GPA over here, centered GPA over here. So if I go ahead and rearrange my terms, taking the B2 and B3 here for my dummy codes and placing them over here with the B0, these are going to reflect how B2 and B3 are going to change the intercept. Take my B1 with the X and place it over here, and then this is my initial slope, and this is going to reflect how the slope changes as a function of engineering majors and business majors. I can then go ahead and factor out the X, making it clear that here I have an intercept, here I have the slope and what changes the slope. Intercept and what changes the intercept, slope and what changes the slope. So then if I have an engineering major, I plug in 1 and 1, and the B3 cancels out because that's a 0. B5 cancels out because it's multiplied by a 0. That leaves me with B0 plus B2, how the intercept changes as a function of being an engineer. B1 plus B4, the initial slope and how the slope changes. Then over here, I have for business majors, I get the B0, the B3 this time, the B2 cancels out, multiplied by the 0. This should be a B1. B1 plus B5 for how business majors change. And then for the liberal arts majors, basically this cancels out, this cancels out, this cancels out, this cancels out. So I'm left with a reduced form such that y hat equals B0 plus B1x, simply the slope, the intercept and slope for the liberal arts majors. So this is for business. This is for business. This is for engineers. And then this is for liberal arts. In order to plot the data, what you want to do is go back to your original output where you had the constant engineer business, center GPA, engineering interaction, business interaction. These coefficients are going to be used to get your figure. Go to, it's downloadable from Blackboard. Go to the Excel sheet where it says interaction between a categorical and a continuous IV. We're going to go to 3 groups, and I'm going to go ahead and change these real quick. So in order to do this, what you want to do is first go ahead and just put in the terms for your that come from your output. So my constant was 20,98983. Then it has the x coefficient, the continuous variable. That is right here for center GPA. So that is 789. And I guess I can round that off to 790. And then your coefficient for the first dummy code engineer was 7063 rounded off. And then the coefficient for the business major, that was 2622. Then your interaction term for the first code, minus 667, that was already in there. And then the one for the business major is 1082. Following the dummy coding scheme here, my 0-0 group was liberal arts. My 0-1 was business. My 1-0 was engineering. Last thing I need to fiddle with is the low value for X and the high value for X. Go ahead to SPSS and go to descriptive statistics. On descriptives, let's look for my center GPA. And I find that my minimum is 0.85 and my maximum was 1.22. So minimum minus 0.85 and maximum 1.22. And that gives you a nice representation of your data. Okay, last piece. How to do this the simplest way, using process. Go to Analyze, Regression, Process. And we're going to put in salaries for our Y variable. We're going to put in college as the moderator. So it's going to do the coding for us. And it has a box over here that says multi-categorical. So we're going to go ahead and say that W is multi-categorical. We're going to go ahead and use the indicator system, which basically does a simple dummy coding system using ones as the 0-0 outgroup. And then we're going to put in our original GPA as the X variable. When I go to options, I'm going to ask for it to test the X by M interaction. I'm going to ask it to center just GPA, so only the continuous variable, the defined products. And I'm going to ask it to generate the code for visualizing the interactions. Go ahead and run that. By the way, it has to be on Model 1. It's Model 1 to do this. And here is our output. And it shows, to start off with, that the model as a whole, all of these variables account for a substantial variance, not really of interest. Then it shows for the liberal arts majors, here's the amount that they're making. It's significantly different than zero, which is not usually of interest. GPA for the liberal arts majors is 789. It's a significant slope for the liberal arts majors. Here's our dummy codes, dummy 1, dummy 2. This is for engineers. This is for business majors. So it's a $7,000 boost for the engineers above the 20,000 for liberal arts majors. That's a significant boost. The business majors are making $2,600 more than the 20,000, 21,000 for the liberal arts. That's a significant boost. You also get confidence intervals in here, which are cool. The interaction for the liberal, for the engineering majors is significantly less than of a slope than for the liberal arts. And the slope for the engineering majors significantly more than that, than the slope of 789 for the business majors. What's really cool is that it does the same thing as a hierarchical regression here, pulling together the two interaction terms to give you your interaction for both of these together. And so that allows you to say that the interaction of college by GPA with 2 and 44 degrees of freedom gives you an F of 25.8, which is statistically significant. And then what's super cool is that it also gives you the simple slopes. So here it is for the liberal arts majors, coded 1 in college. 789, as we've already seen before, that's significant. For the engineering majors, the slope is non-significant at 123, and for the engineering majors, the slope is significant and mighty strong. And then finally, what's super cool is, or super cool, is that it gives you a code for being able to generate the plots. So you double click so that you can get inside here. Go ahead and copy this little program. It's written its own SPSS program, is the nature of that code. So you basically take that, you open up syntax, open up a new syntax, go ahead and Control V, drop the code in there. It's a whole program for running of olden days notation for running a program, and you run that, and it gives you a nice graph. Double click on the graph, go over here where it says add fit line at subgroups, and it puts lines through the subgroups. And there you go. Now you have a nice figure, which I would copy and paste over into PowerPoint and mess with it over there to make it pretty the way that I would want. But it is showing you what we saw at the beginning, that the engineers are making the most with hardly any slope, GPA not mattering much, GPA matters the most, business majors are making the second most, Liberal arts GPA matters some. Liberal arts is making the least. Okay, that's it for looking at the interaction between a categorical variable and a continuous variable. I hope you enjoyed it. Ta-ta.